systems of linear equations today. I want you to work with your groupies. Go ahead and complete X. You can determine the number of solutions of a linear system. This is a really quick review of solving two-variable systems, because today we're going to be doing three-variable systems. Okay, so work together, do exploration 1. Please keep it down while I'm getting rolled. Hey, we're solving linear systems, and quick review of two-variable. How many are here this summer? That's going to help you out a lot today. Those of you who weren't here, you can rely a little on those other people if you've forgotten, hopefully. If we're matching each linear system with its corresponding graph. In this case, what I would do first, looking at these two lines here, you only see one line here. Okay? Remember, a solution to a system is what? How do we find the solution? Like if I'm looking at a graph, how do I know a solution? Emma? Yeah. Yep. Very good. Good. So C is one solution because they cross. The actual solution is the ordered pair 3, 1. Whereas this is no solution because they're parallel lines. They don't cross. And letter A, since we're assuming that we have two lines, that one's infinitely many solutions. Okay? Now notice they use the terms consistent and inconsistent. A linear system is consistent when it has at least one solution. Okay, it's inconsistent if it has no solution. So like B would be considered inconsistent. Now if I'm taking a look at this and I now go up to the equations, the first thing I see as someone who's done math for a while is I start going, well man, on these equations, I can reduce some of these equations. Just like fractions, I can look at this, 2, 3, and 3, nothing goes into that, but 4, 6, and 6, what number goes into both of those? 2. In fact, if I want my A term to be positive, I could pull out a negative 2. I could divide this by negative 2, or multiply it by, actually let's make that a negative 1/2. Okay? If I multiply it by negative 1/2, this actually becomes 2x. So that would become 2x. This would become negative 3y, excuse me. And this becomes negative 3. Okay, how many are with me what I did there, reducing? Okay, explain to me what the benefit of, you know what, let me rewrite that so it looks nice and clean. Okay, what's the benefit of doing that? Yeah. Okay. Any others? Let me focus in right here. How is that helpful? Yeah, these things are identical, right? So if 2x minus 3y equals 3, and here you're saying 2x minus 3y equals negative 3, really, tell your neighbor what statement are you actually saying. All right, so judging from just the voices I can kind of hear, you guys have no idea what I'm saying. Okay? Basic skill in algebra is substitution. If one thing is identical to another, you can use substitution. If you're saying this equals 3 and this equals negative 3, you are really saying 3 equals negative 3. Because both of these are the same thing. 3 equals negative 3. Is that true? No, that's never true. That goes with letter B. Okay? So these two match up. All right, now, can I reduce any of these other equations? Yeah, see, I could. If I take negative 2 out of the bottom, everyone go ahead and reduce the bottom by multiplying it by negative 1/2. Thank you. Okay, multiply that by negative 1/2. Okay, what do we get? Okay, 2x minus 3y equals 3. How is that helpful? Kelsey? Good. You know these are the identical, so now we know 3 equals 3. Is that true? Yes, and that's always true, so that is infinitely many. Letter C goes with graph A. Okay, those two match up. Which implies letter B goes with B. Or no, I'm sorry, letter B goes with C. Yeah, man. So if I wanted to check that, I know this is a solution. I can just plug it in. 2 times 3, that's 6. Minus 3 times 1, which is 3, equals 3. Is that true? Yep. So it's a solution to that one. Try this one. 3 plus 2, does that equal 5? Yep. So that goes with that. Now, did we use any solving of system? Like, did we use substitution or elimination? No, we haven't used any of our strategies yet. We've just used some reasoning to figure it out. Well, let's review some of those strategies. If I am going to use substitution and elimination, exploration 2. Okay? Solve the linear system by using substitution and elimination. Tell your neighbor which one you're going to use for letter A, based on what you remember. If you're not sure, pick one. Okay, how many say substitution? How many say elimination? You guys aren't all voting. You got to pick a side. How many say substitution? How many say elimination? Okay, elimination would be the easiest one here. So you had it. So let me pause for a minute. Like I do this fantasy football league. It's called the Pick'em League. It's with some of the teachers here, and all you do is pick a winner of a team, and you can't pick the same team more than once. And so, like, there are teams that I could care less about, but eventually I got to pick them to win because I have to use one team each time. So, like, I have no vested interest at all in those games, but I still pick a team. When I tell you to pick one, I'm trying to get you to root for a team. So you just had a team you were rooting for. How many were rooting for substitution? Team substitution. How many are rooting for team elimination? Okay, if you didn't pick a team, dude, that's unbelievable. Yeah, you're like team language arts or something. Okay, so nothing against language arts. All right. Now, let me tell you which team I think would. Now, both teams could win. It's like soccer, which is lame. But no, I'm just joking, Kelsey. Sorry. I know. All right, I just don't like the tie ball game, you know. But, you know, either team could win here. I'm just telling you that the team that will get you there faster is elimination. Why? Because Y and Y are negatives, or opposites of each other. So when I add elimination, when you add together the two equations, these two things cancel. And I'm left with 3x equals 6. I have eliminated the variable y. Okay? What does x equal? 2. All right. All you soccer fans out there, I'm sorry. I apologize to you. Yes? No, we're not there yet, dude. You're jumping ahead. All right? Okay. Hey, everyone's done talking now. If x equals 2, how do we find y? Raise your hand, please. How do we find y? Yes, Scarlett? Yeah, you plug it back into one of your equations. It doesn't matter which one. You plug it into the top, you get 2 times 2 or 4, plus y equals 5. Subtract 4, you get y equals 1. You get the ordered pair, 2, 1. Okay? Tell your neighbor what you're going to use on letter B. What's going to be the quickest way? Substitution or elimination? Okay, volunteer. How many say, actually, let's vote. Substitution. Elimination. Elimination will go quicker. How come? Raise your hand, please. Why elimination? Okay?
The x's are opposites.
X's are opposites already. You add together, you get 0, and now you have 5y equals 5. And that means y equals 1. And just let me be a little more clear on how to get the x value. If you take either equation, so I'll take the top equation, and plug in 1 for y, so x plus 3 times 1 equals 1. So I get x plus 3 equals 1, and x equals negative 2. So we get the ordered pair, negative 2, 1. Remember, that's a point on the graph. That's where those two lines would cross. Okay, questions? That is, look, I look at that, what I just did there with the line and the box, that makes me feel very artistic. Yeah. Yeah, because I'm outside of the straight linear, you know. I know, getting crazy. Hold on. There, now I've actually. I know. Whew. All right, letter C, substitution or elimination? What just happened, man? Oh.
It wasn't me.
Uh-huh. Okay, how many say substitution? How many say elimination? The answer is, I would say substitution. Okay, now you could use either one. If you chose to use elimination on this one, hey, pause for a minute. If you chose to use elimination, then you would have to, well, tell your neighbor. You guys tell your neighbor how you do elimination real quick. Okay, here we go. Hey, if we use substitution, if I'm going to use substitution, I'm going to bring the x over or bring the y over. So I get negative x. And then I'm going to plug this x in, this negative x in for y right there. Okay? So I get 3x plus 2 times negative x, which gives me 3x plus, or excuse me, minus 2x equals 1, or x equals 1. All right? And then I'm going to plug that into my equation, x plus y equals 0. So if x is 1, 1 plus y is 0. So y equals negative 1. That is blurry. Okay, think we got it? Okay. Let's compare it to our graphs right here. Hey, notice A. Is that the ordered pair 2, 1? B, negative 2, 1. Is that point? And C, 1, negative 1. All right. If you take a look at page 19 of your student journal, later on if you'd like, okay, you're talking when I'm talking, which isn't going to work, okay? If you would like to, you can finish up this part down here, 3 and 4, but really what I want to focus on now is what we're trying to get through today, which is solving 3 variable systems with x, y, and z. Okay, so the 2 variable where you warm up, your quick review. Now we're going to go through dealing with x, y, and z. Okay? So, in order to make it through this, you have got to quit talking every time you get a chance, unless it's structured discussion, which is when I ask you to discuss something. So, I don't like really the way they put equation 1, equation 2, and equation 3. I'd prefer you call this equation A, B, and C. Okay, and our goal, make sure you're clear on it, our goal is to eliminate, obviously our ultimate goal is to solve for x, y, and z, but to begin with, eliminate the same variable from all three equations. Okay, that's how we start this problem. First goal is to eliminate same variable from all three equations. And then we can solve a two-variable system. So if I can eliminate x, then I'd be just left with y and z, and I know how to solve a two-variable system. Okay? So, looking at this, if I look at a, b, and c, which ones, or which variable should I eliminate? Yeah, some would say x, some would say y, some would say z. And this one, it really is, which one do we want to pick? All right, we'll go with x. So if I'm going to eliminate x, from equation A, what do I have to use? What other equation? C. I'd use A and C. What I'm going to do is I'm going to take equation A, x plus y plus z equals 1, and add that to equation C, which is negative x minus y plus z equals negative 1. Okay? I write it like that. However, you'll also see me write it like this a lot in a box. I'll say, I'm just going to do a plus c. Make sure you really stay organized. Okay? So when I add those two up, that disappears. In fact, my y's disappear and falls out really nice. 2z equals 0. So z is 0. Now that will not always happen. Just so happens when you add those two, you get an answer. There you're like jumping for joy. Two variables eliminated at once. Like 2 for 1, man. Okay? What a sale. All right. I eliminated x. Derek, how you doing? Okay? I eliminated x from A and C. I now need to eliminate x from one other equation. Which equation? Which one haven't I used yet? B. So, if I'm eliminating x from B, which other equation should I use? C. So I could say I am going to add B to C. Which would mean, if I'm doing that, that would be B, x minus y minus z equals 3, and C, negative x minus y plus z equals negative 1. We add them up. X's cancel. Left with negative 2y. Z's cancel. Dude, 2 for 1 again. And positive 2. So y is negative 1. Now that doesn't always happen. We've just been lucky so far. You get 2 for 1. Tell your neighbor how you're going to find what x is now. Okay, let's pick an equation. A, B, or C? A. So if I take equation A, you can use any. If I take equation A and plug in z and y, and then solve, x equals 2. That is an ordered triple of 2, negative 1, 0 or hero. X, Y, Z. Now, we've talked about what these look like in two-variable systems. When you're looking at three-variable systems, that picture right there, yes, it's rain. We'll be okay. We live in the Northwest. All right. Back here, three-variable systems, when you have an ordered triple, they all hit at one exact point. You're graphing planes. X, Y, Z, you're dealing with planes. This is on page 30 of your textbook, so if you want, like, of your actual book. Okay? So if you have a book at your desk, some of you don't have books at your desk. You'd have to use your own book, but you can just look up here. Okay? If you had three planes that intersect in one point, that gives you exactly one solution. Whereas if you have three planes that intersect in a straight line, they don't intersect in one point, They intersect in a line that goes on forever. That's infinitely many. It's like a three-dimensional asterisk, man. Okay? And then those no solutions would be where your planes don't even all intersect at the same, in a common area. Like they could form a teepee, or you could have two parallel planes and a third running through. Or three parallel planes. Okay. So let me, all right. I want you guys to go back to your student journal. If you take a look at page 20. We got it. On page 20, later on. Man. Guys, let me point out, if you're wanting to at home just to review, these are good pages for you to go through and just rewrite what you did today and review the stuff. But here are your steps to solving these. So later on, if you want to take a look at the steps, it may help you out. All right? We're going to try a couple problems together. I want you to take a look at this problem, write it down. Remember, this is out of your textbook. It is not out of your journal. So, number 1 is the one we're going to go through. Letter A, letter B, and letter C. Our goal will be to get through these 3 problems before we leave today. Okay, we'll start with number 1. Okay, tell your neighbor how you're going to go through and solve that. Get it. Actually, we better get through one more. I have one more. Okay, if I want to eliminate the same variable, which variable will it be? How many say Y? Z? X? Yeah, you can use any of them there. Like you have opposites in each of those. Okay? I'm going to start with, I think I'm going to start with Y because that was the first one I heard. They all have 2's anyway. So if I'm going to eliminate Y using A and B, I'm going to take A and do what? Add it to B. Okay, so if I go A plus B, well that's X and 3X is 4X. Negative 2Y and positive 2Y is 0. And Z and negative Z is 0. That's nice. So negative 11 and 7 is negative 4. So X equals negative 1. Once again, it's rain. We'll be okay. We've seen it before.
What?
Yeah, I know.
Whoa. No way.
Okay, so I've eliminated... I was trying to eliminate Y. It just happened that Z fell out too. I want to now eliminate Y from which equation? From C. Okay, so if I'm going to eliminate Y from C, what other equation am I going to use? A. So I'd have to take A, because it has the negative 2Y and C has the positive 2Y. A and add it to C. So X and negative X is 0. Negative 2Y and positive 2Y is 0. And Z and 4Z is 5Z. 5Z equals negative 20. So Z is negative 4. Can we pause there? Any questions up to that point? Ask your neighbor if they get it. Questions? All right. What am I going to do now? Haley. Good. Substitute these two into one of my equations. So if I use, say, equation A, use X, negative 1, minus 2Y, plus 1Z, or negative 4, equals negative 11. Substitute it in, I get negative 1 and negative 4 is negative 5 minus 2y equals negative 11. Negative 2y equals, we add 5 to both sides, negative 6, and y is 3. So we get the order triple, negative 1, 3, negative 4. How many solutions on that? One solution, right? Right here. Visualize what the picture looks like. All three planes intersect. 1 point. Okay, I want you to try number 2. Come up with a plan, like I'm going to eliminate this variable using these equations. Talk with your group about it. Okay, what are your plans? Someone give me their plan. Chase. Okay, you're going to go A plus C to eliminate Z. Okay. Good, so if you didn't have a plan, there's a good start. Give it a go. Okay, so sounds like we need to figure out, like when we go x and 3x and get 4x, y and 2y is 3y, and negative 1 and 0, or z and negative z is 0, negative 1 and 0 is negative 1. Now, when you're done there and you get another equation, just label it equation D. Okay, and now we have to eliminate z from B. How are we going to do that? Emily? You'd have to, we have to get rid of z first. We have, Kelsey? Good, so you could use 4c. If we multiply this one by 4, that would give us opposites here. So we go 4c plus b. That would work. So 4c, I'm going to rewrite that right here. 4c would be 12x, 8y, 4z, and still 0. Plus b, which is 4x, 4y, minus 4z equals negative 2. Now notice we could have simplified, we could have reduced b at the very beginning if we would have wanted to. But that's okay. We combine these, we get 16, 12y, okay, and what we call that equation? E. Now really what we're trying to do is we try to eliminate x or y from D and E. Now before we do that, can we reduce either of those? Yeah, let's try to reduce this one. Everyone reduce that equation. Okay, what can we take out of it? 4. So you're really taking 1/4 of equation E. 1/4 of equation E is 4x, 3y, and, no, not 1/4. I have to take a half, sorry. So it would be 8x. This would be 6y. And negative 1. 8x, 6y, and negative 1. All right. Hey, if I look at this and this, notice this is 4x plus 3y, this is 8x plus 6y. And both equal negative 1. So what happened if I mean the next step really is to take equation E, which we could still call this equation E or that, and try to eliminate one of the others, but notice this is double it. If I doubled this, I'd have 8x and 6y and negative 2. So I'm now saying 8x plus 6y equals negative 2. And I'm saying 8x plus 6y equals negative 1. Is that possible? Negative 2 cannot equal negative 1. That's a no solution. That's it. That's it. Hey, let's look at number 3 real quick. Number 3, this is A. This is B. This is C. Okay, let's try to eliminate which variable? Y. So we'll go A plus B. A plus B, we get 2x plus 2z equals 16. Dude, the y's cancel. And now we could go like B plus C. This is equation E now. Oh, equation D. We could call it E, but we'll call it D. Okay, let's go B plus C. How many x's? 3x. How many y's? None. How many z's? 3z equals 24. Okay, we call that equation E. Can you reduce this one? Yeah, you can reduce both of them actually. This one reduces to x plus z equals 8. How about this one? X plus z equals 8. Notice now you have the exact same thing again. So you have 8 equals 8. That is infinitely many. Bless you. Squared. All right. Ladies and gentlemen, I need you to take your student journals, please. Open it up to page 21.
Oh, yay.
All right. Ladies and gentlemen, I will tell you that a lot of you will want to show your work on a separate sheet of paper. But for now, we're going to start number 1 together. Your assignment's going to be 1 through 4. We're going to do as much of 1 as we can. You can do them all if you want. Okay. On number 1, which variable am I eliminating? It's a little tougher, right? Okay, so maybe we start by eliminating z. Okay. So if I multiply like these two, b plus 2c. Okay, that's 2c is going to give me a 2 here. So I go 2x plus y minus 2z equals 9. That's b. And I add to it 2c. That's going to give me 8x plus 6y plus 2z equals 32. 10x, 7y, 0, and 41. Yuck. Those are nasty numbers, dude. We're going to call that D. All right. Now, I need to eliminate Z from A. How am I going to do that? Okay, go 3C and add it to A. So 3C is 12x, 9y, and 3z equals 48. A is x, 2y, 3z, negative 3z equals 11. That's gone. 13x plus 11y equals 48 and 11 is 59. Once again, those are pretty ugly, man.
Yes.
This is E. You now have to eliminate something from D and E. What do you want to eliminate? How about X? You at least have a 10. Could we use X? We at least have a 10 there. Okay, so if we go 13D and 10E, okay, so negative 13D plus 10E. Sorry, man. That's what maybe we should eliminate a different variable. My other class, it went a lot easier, but we used a different variable. Oh, that's all right. Hey, we're already into this one. Come on. Okay. All right. Just so you. Okay. So next step here, we have to negative 130. X minus 13 times 7. So minus 91y equals 41 times 13, 533. So that is negative 13d. 10e, so we have 10 times 13, or 130x. 10 times 110, much easier, 100, or 10 times 11 is 110, and then 10 times 59, 590. Get 0. Oh, let's see, 19y. And so 57, and y equals 3. By the way, if we would have solved for x, it would have been much easier first. You don't get all these big numbers, so sometimes when you get big numbers, try to solve for a different variable first. X, it drops out a lot nicer. But we already started this one, so we'll keep going. So I'm going to plug that into equation. Maybe I'll put it into equation D here. So D, we get 10x plus 7 times 3 equals 41. 10x plus 21 equals 41. Subtract 21 on both sides. And divide by 10. And then plug all x and y back into one of my original equations. So if I choose like equation A here, so go ahead and use my equation A. So x plus 2, oops, it's supposed to be a minus, so x plus 2y minus 3z equals 11. And we'll plug x in for 2. Y is 3. We'll solve for z. So we get 2 plus 6 minus 3z equals 11. Gives me 8 minus 3z equals 11. Negative 3z equals 3. Subtracting 8 from both sides of z is negative 1. The order triple, 2, 3, negative 1. Then you can check it by plugging it back into all three of your originals. So you have 2, 3, negative 1. We know it works in A because we just put it in A. But 2 times 2 is 4, plus 3. Negative 2 times negative 1 is 2. So 4 plus 3 is 7, plus 2 is 9. That works there. 4 times 2 is 8. 3 times 3 is 9. Minus 1, that's 17 minus 1, or 16. Works out. Woohoo!